try this n queens thing. Sorry, I'm like, my tech lead is like messaging me while I'm trying to do this, so so I need to entertain 2 conversations at once, but that's okay. So in this n queens puzzle, you have an n by n chessboard, and no 2 queens can attack each other. Internal distinct solution to n queens puzzle. You may answer it in any order. So one thing to keep in mind when they say distinct, meaning, order does matter and things of that nature, you should think about permutations as opposed to combinations. Combinations meaning, like the previous bit masks videos earlier, I think I made a verbal error saying that was for permutations. You can filter for permutations, but it's really for combinations. So for example, if you're making a 3-card hand, that's more of a combination because you don't really care which order you're dealt the 3 cards. Those 3 cards still make a hand if it does. Anyway, cool. So for this problem, one of the things is like I can check if, I can kind of go through all these permutations and kind of see like, well, can I, like just put a queen on every single spot with k queens, and then seeing if, those are legal. That might take quite a bit of time because you need to place it, at 64 spots times 65, 64, 63. So we should probably prune things out and then check if, queens are in the same rank or file. Check if queens are in the same diagonal. And then what you could do is you could probably have a recursive loop where you say, all right, queens here, and I already know I can't place anything on this file, so I'll place something on, either here, 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 or here, but probably not here because it's the same file or rank. It's also not here because it's the same diagonal, and so on and so forth. And as we place each queen, we can keep an array of like all the diagonals and perhaps all the files it's taken. But the rank is the file. Yeah. So no, the rank's not file. So if I say, I place a queen here, then no other queen can go to 0. If I place a queen here and here, no other queen can go to 0 or 2. Yeah. I'll just call it column because I don't know if rank or file is the correct, usage of this. So what do we need? We need a recursion function, and we know n, but what do we want to pass in recursion function? So let's see if there's a way to check the diagonals. So for example, if this was like 3, 2, right, then your diagonal is gonna be 2, 2, sorry, 3, 3, this is 4, 4, 4, and then if your other diagonal will be 2, 4, and also 4, 2, and then probably 5, 1, and 6, 0. So you can see kind of a pattern here where they add up to the same constant. That might not be, yeah. So maybe if we formalize it to I comma j, then we have like 2, 2, 3, 3, 4, 4, 5, 5. So it's like I plus k, j plus k. and then I, comma j, first diag, and then the second diagonal, we would have -1, +1, +1, -1, +2, -2. So, I plus k, I, j minus k, second diag. Now I'm very curious because the sum adds up to the same, so is it not possible for 6, so 3, 3, 4, 2. Suppose 1, 5, that'll collide. Suppose 5, 1, that won't collide, even though it adds up to 6, because 3, 4, 5, and 1, right? So we can't say that. So it really does seem like, you know, you just keep adding 1, or 2, or 3, or 4, and then on the flip side, so like on the right hand side, you just keep adding, right? But as you keep adding, then of course you're rising or subtracting I, or your row number. So they're kind of going in opposite directions here. So if I say, you know, for any is invariant so one can say, hey, if I have this relationship between these, and these are if and only if relationships, because you could kind of reason it out by literally drawing a diagonal. So for example, this would be, you know, plus k, like +1, +1, +2, +2, +3, +3, -1, -1, -1, -1, right? So this will give you a very clear visual of, yeah. So there's nothing else where you do 2 plus k's and it's not going to lie on this diagonal, and there's nothing where you can do plus k minus k that's not going to lie on this diagonal, right? So, so dag 1, dag 2 probably array of minus j's. So that'll kind of say what diagonal it's on, and then dag 2 is an array of my plus j's, and then we can kind of check things and prune things out pretty quickly. Queen on columns. So this is queen on columns. This is an array of where queens reside. So if I'm in my n chessboard, I must have n queens, or yeah. Then if length of queen on calls n, then go ahead and answer is the answer. Answer dot append queen on columns. On calls I, where I is row, and then queen on columns is value is j, j being the column. Okay. And then the tricky part, I call recurse here. So I want the queen to be placed if I'm on the very first level. Then I want to place things here, 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 here. So for I in range 8 or n, let's maybe be more explicit. For call in n, I want to check if it violates anything. So if queen on columns well, actually this is just I, because you're gonna place at max one of these here, and then in the same level, like you're gonna put another one of these in here. So yeah, it is columns actually for column. Is that true? No, that's not true. If for column in range n, if the column isn't already in queen on columns, and so I guess my thinking is, yeah, let's place it here. Then y is my column. Y is not in here, then we will try to place the next one. Let's add the conditions later. Let's maybe say if it passes the checks, then I can add some column in. And then each depth I guess I'm missing an x, because I can just add this invariant in here. queens reside. Okay. Yeah, it is the rows actually. The length is the rows. Because if you have, let's say, queen on columns I, and you have two of them, then you're working on the third row. And then on the third row, you're going to loop through all of the possible combinations, and you're going to do a bunch of checks. So cool. So X is this, and this call is called. And let's just go back to the invariance where we say, so answer will be this X and Y. So it'll just be basically each row, and then it'll be like, 2, 1, 3, 0, 2. And then so this is basically saying 0, 1, 1, 3, 0, 2, or 2, 0, and then 3, 2. And then so what we can do is we can just say, just convert these. So how do I convert these easily? For solution in answer, for the solution in answer, I probably want to do for row in solution, then answer in string, So I basically want, if this is 1, then I would do like for column in solution, then I would do would do times row plus no. So let's say it was 1, then I would do times column, so the number of columns with that's dots to the left of it plus the queen plus dots that are of n minus column. So if column was 1, how many dots do we need? If the length was 4, 4 minus 1 is 3, 3 minus 1 is 2. Solution.append and then do this, and I guess the rows don't matter because you can only have one queen, one row, and one column. And once you're done, go ahead and answer in string.append current solution. See if it breaks. Oh, I need to run recurse. I haven't placed any queens yet, and I haven't had any diagonals yet, but we'll generate these diagonals. Queen, no. So what is the length? So it's 2, and 2 minus 3 is -1. Diag is -1. So it is in here, so it should violate. sorry, it's y, x, but yeah, I mean, it's row column, so x and y is misleading, so I think. Interesting. So here, appending to, we have like here. And so I go like 0, 1, 2, 3, I find nothing, but why do I do 3 again? Why does it do 2, 3 twice? What is going on? So for column in range n, so once it reaches 3, it should break out of it and return nothing. So then the very top stack, or at least, yeah, the very top stack should move on to to this guy. Is there some... Oh, I see. this became global. When this becomes global, it thrashes everything because you can't unplace a queen. Okay, well, I guess, let's see. Seems like weird if it works for that one but not other ones. Anyway, yeah, so I solved this, and yeah, it's kind of hard to solve it. But the bamboozle is, this solution is actually something that was in the discussions, and I kind of understood it at a high level, but it's like the struggle was real, as you can see. Like in an interview, it's a lot more important to just kind of know the ideas and concepts and sort of memorize those, as opposed to trying to figure out stuff from scratch. Like no one is actually going to figure this out within a 45-minute period. I'm sorry, like you're not going to. And if you are, then you're pretty damn good competitive programmer. But then you're very good at competitive programming as opposed to doing anything anyway. But yeah, in order to over optimize being a competitive programmer, you probably want to just memorize things like this. So then in a bind, you can at least kind of recall the invariant, just like math, and like using math to create the basis and then spending the rest of the time implementing the solution. And then once you implement the solution, it's very likely that someone else didn't remember it. It's just there's no way that they would actually create it. And even though I knew the math basis, explaining my thinking is good because it shows that the struggle is real. Like I kind of knew up to this part at the beginning of the video, but like it seemed like I was figuring it out in time. I think the X and Y and stuff is something that I should think about a bit more. Like I think this is good that I wrote it here, but I kind of just forgot that I wrote this. It was shortened some struggling, some thinking. And the last thing, make sure your code is congruent. If you're doing plus D1 plus D2 here, don't go ahead and append it to this reference queen call, because then you're just asking for trouble. But I know that if you're coding for a long time and grinding LeetCode, focus is a very, very difficult thing to keep for like hours on end, especially if you're old like me. Anyway, I hope this helps. The lesson is there's no way you could derive this and implement it. So you might as well have the information of this cached and then spend the rest of the time trying to implement it, and then you'll be at a much bigger advantage than otherwise. Because there's a lot of sort of math and implicit and indexing involved, and with implicit indexing, you're much better than the guy that spends 15 minutes deriving this, whereas you can just pretend to struggle for like 5 to 10 minutes and then figure out the big idea and then go ahead and bang, do it. Anyway, that's it for this video. See you in the next.